Hello friends, so here is another question on SHM equation. So it is given that the equation of simple harmonic motion SHM, it is given by x is equal to 6 sine 10 pi t plus 8 cos 10 pi t, okay, in a different way, where x is in centimeters and t is in seconds. We have to find the time period, the amplitude and the initial phase of this SHM motion. Okay, so here the SHM equation is given in a different way. It is given SHM equation is like this: x is equal to 6 sine 10 pi t plus 8 cos 10 pi t. Okay, this. What is the standard format of SHM equation? Okay, the standard SHM equation form, that is like this: x is equal to a, let's keep it sine, okay, a sine omega t plus phi. A is the amplitude, omega is the angular frequency, t is the particular time instant, phi is the initial phase. So here if we use the trigonometric identity sine a plus b, which is sine a cos b plus cos a sine b, if we use that, it will be like this: a sine a plus b, where a is omega t and b is phi. It will be sine omega t cos phi plus cos omega t sin phi, like this. Or we can write it as a cos phi, keeping it together, sin omega t plus a sin phi cos omega t, this. Now please focus on this equation, okay, this equation which we derived from this standard SHM equation, and this one. These two, if we compare, we will find a similar pattern, where here it is sine something t, here also it is sine omega t, here it is cos some parameter value t, here also cos omega t, and here we have a cos phi, here it is 6. So here a cos phi is equal to 6 and a sin phi, the cos part, a sin phi, here it is equal to 8 when we compare. Okay, these two we got. Then the angular frequency, sin omega t sin 10 pi t, cos omega t cos 10 pi t. 10 pi is constant in both the cases, so the angular frequency is equal to 10 pi radians per second. Now we know that angular frequency is equal to 2 pi f, where f is a frequency in second inverse or hertz, or we can write it as 2 pi into 1 by t. F is equal to 1 by t. So t, or time period, will be equal to how much? 2 pi by omega. 2 pi by omega. So here if we put this value, omega is equal to 10 pi here, it will be 2 pi by 10 pi, so it will be how much? 1 by 5 seconds, which is 0.2 seconds. That is the time period. Okay, the first thing which was asked, calculate the time period which is equal to 0.2 seconds. Then for the amplitude, okay, a cos phi is 6, a sin phi is 8. A cos phi is equal to 6 and a sin phi is equal to 8. So here if we square them and add them together, that is a cos phi whole square plus a sin phi whole square, it will be equal to 6 square plus 8 square. That implies here, so here it becomes a square cos square phi plus a square sin square phi is equal to 36 plus 64. Okay, that implies a square into cos square phi plus sin square phi is equal to how much? 36 plus 64, it will be 100. That implies a square into sin square phi plus cos square phi, that is equal to 1, that is equal to 100. That implies a, the amplitude wise, it can be plus minus 10 centimeters. Okay, that is the variation of the either side of the mean position, the peak displacement. So this is the amplitude. Okay, so we have got the time period, we have got the amplitude. Now for the phase angle, a sin phi is equal to 8, a cos phi is equal to 6. So if we calculate the ratio between the two, a sin phi by a cos phi, that is equal to 8 by 6, or that is equal to 4 by 3. That implies a cancelled, sin phi by cos phi is equal to tan phi is equal to 4 by 3. That implies tan inverse of 4 by 3, that is equal to 53.12 degrees. That is the initial phase angle. Okay, this is the thing. Okay, so here a very different form of question was given, and from that we determined the values. Okay, so here is another question on simple harmonic motion. So it is given that if a particle executes SHM, that is simple harmonic motion, with a time period of 8 seconds and amplitude 0.40 meters, we have to find the maximum velocity and acceleration of this SHM motion. So here the concept of acceleration and velocity, those two things come into play. We know the standard SHM equation, it is given by x is equal to a sine omega t plus phi, where it is sometimes written in terms of y or x, whatever. It is the instantaneous position with respect to the instantaneous time. A is the maximum amplitude, the maximum displacement from the mean position. Omega is the angular frequency and phi is the initial phase. Here if we differentiate this displacement equation with respect to time, that is dx by dt, we will get velocity. Okay, and that is equal to how much? It will be coming a omega cos omega t. So this velocity, it will have a maximum value when this cos thing will be equal to 1, omega t will be 0. So maximum value is a omega. Again, if we differentiate this velocity again with respect to time, or we perform double second order derivative of this displacement equation, it will be equal to minus a omega square sine omega t. Okay, and this will have a maximum value, which is the acceleration. Okay, this is the acceleration of the SHM motion, and this will have a maximum value when the sine thing it becomes equal to 1, and that maximum value will be equal to a omega square. So if we only consider the magnitude, it will be a omega square. So here we have information related to the amplitude a, which is equal to how much? 0.40 meters. But from these two equations, for the maximum value of velocity and acceleration, we need the angular frequency omega. So that will determine from the time period. Given the time period is equal to 8 seconds. Okay, now we know that omega is equal to 2 pi f, which is equal to 2 pi by t. That implies here, if we put the value of t here, 2 pi by t, will get the angular frequency, that is 2 pi by 8, which is equal to pi by 4 radians per second. So we'll simply put the value of this omega is equal to pi by 4 per second to get the maximum velocity first. So V max will be equal to a omega, that is 0.40 into pi by 4, which is equal to, it is coming around, let's calculate, it's coming around 0.3142, okay, meters per second. Yes, the unit is in meters, I think. Yes, amplitude is meters, so yes, meters per second. And the maximum acceleration magnitude wise only, it is a omega square, so it is 0.40 into omega square, which is equal to pi by 4 whole square. So it is coming around 0.2468 meters per second square. Okay, so here these two parameters we were asked to find it. Okay, the maximum value of velocity and the maximum value of acceleration. So we got it. Okay, again a very good basic question related to SHM, simple harmonic motion equation.